So I'll take you through this unique product, autoclaved aerated concrete. Is of course it's a green concrete. Why it is green? So I've structured my presentation around these areas. Like we talk about the product, we talk about this feature of the product, why it's green, how it is compatible in terms of green rating systems. A brief about the manufacturing process, sustainability aspects, and overall wrap it up why and how it can really contribute to the nations. So when you talk about a green concrete, the primarily green concrete is the product, this when there is a major component of raw material comes from alternate industrial waste kind of material, and also that ensures a life cycle sustainability factor. This is one of the important component of green concrete. Then green concrete also made from any supplementary materials, like we're using fly ash here. That can be for other industrial waste, of course, because we extract from any concrete the silica, the calcareous portion is very important, calcium siliceous factor. So we extract those components from fly ash. And autoclaved concrete is also green concrete because apart from utilizing the fly ash, it also take care of various aspects, like don't use any topsoil or any kind of natural resources, and also enhances the energy efficiency and throughout the building life cycle. So when you talk of AAC, again, it's like any other concrete, it's a chemical reactions forms between the calcareous and siliceous material. And AAC, is more than 100 years. Of course, it started from Europe, and in India, it's more than 40 years. And now it's a very prominent building material across the world because of its unique features. Is in most of the projects or different nature, be it industrial, institutional, residential, everywhere it has its prominence. Now, if you look at the component of autoclaved aerated concrete, as I mentioned to you in the beginning, like the essential component of AAC is 70 supplementary material, that is fly ash. Of course, you can use also sand, but initially when you tried this technology in India in 40 years back, we had an intention, in fact, to replace using the sand, because fly ash, there's no utilization, 30, 40 years back. It is only whatever being generated in thermal power station, they'll dump it, they make slurry and they fill those ponds, there is no prime use of the material. So we have tried and now tried tested, and it's now standard. 90% of places is now fly ash being utilized in manufacturing of AAC. Apart from fly ash, because this component I mentioned 55 to 60%, we have cement and lime in the proportion of 12 to 14% each. And these are three major raw material, in fact: fly ash, cement, and lime. This constitutes around 90% component of the AAC. And then you add the gypsum for controlling the process, and the aluminum powder. That's a very important product here, because based on its doses, it creates the foam, and so that is the foaming agent. It's 0.03%. Its control uses is there of this material, and remaining the balance, that is slurry. So that's the prime component of the product. So what all products, building products, you can using a AAC based technology. So you can use block, solid lightweight blocks. You can use the wall panels, floor panels. These are all reinforced product. You can also use AAC as a lintel. This is also a reinforced product. So if you look at typically the length, height, and thickness of the product, it comes in a range. So you've got a lot of flexibility for the architect and consultant. Now, like the conventional brick, you've been using only 9-inch, 4.5-inch, and 3-inch. So there's a 3 fixed dimensions. It do not have the flexibility to go beyond that. But here it's something different. You've got the length of 600 to 650. This is a wider size, and height 200 to 250. And you can see the range of thicknesses, 100 to 250, and more than that. In fact, 300 also we can produce. If you look at this reinforced product, yes, AAC lintel up to 2 meter, 2.5 meter, you can produce. Reinforced panel, if you want a more faster construction, yes, you can use. Panel can be used as a flooring member, as a replacement for RCC slab, and also in the walling mix. So if you look at the properties of the material, see the density we're maintaining here, 551 to 650 kg per kilometer. This is the density of the product, be it reinforced or unreinforced. This is the density range we follow. The minimum strength we are following for compressive strength for block 30 and little more for the reinforced product. Its thermal conductivity is on an average 0.162, and AAC wall panel is little higher. So its resistance to fire, yes, 2 to 6 hours, because depend on thickness, of the block, it varies. If you look at 100 block, it is 2 hours. If you look at higher thickness block, the more thermal resistance, fire resistance you can achieve. A drying shrinkage limit is also being defined, but when you design your structure, naturally you cannot do it 550 to 650 because that's the oven dry factory conditions. So you have to take the load little higher side when you design your structure, and accordingly will, we were saying that in case of block, you can take 800 kg per cubic meter. And in case of other reinforced product, a wall and reinforced panel is 850 kg per cubic meter. And it has been covered under this BS codes, different codes is there for this products. 2185, part 3, that take care of the specification of the material, the densities and all the parameters I'm talking about that covers under 2185 part 3. Then BIS 6041, that take care of the construction of the AAC masonry practices. And then there are testing codes, and also for reinforced product, there are different codes. So what is the feature of this, this unique material? Yes, it is energy efficient, it is fire resistance, it is acoustically absorbent material, it has got weather resistance, it is very long lasting and durable product, it is environmentally sound, space resistance, easy to use, versatile, and lightweight. So no other, building material or walling material, I should say, having so much wide range of the feature and benefit you'll get for any product. So that's the uniqueness of the material. Out of 10 products, features, I would take this the most prominent one, and which is really useful for if you design your structure using AC. This is the most important factor, is the density of the product, because if you look at the other comparative walling material, AC, hollow block, cement concrete block, clay brick, and concrete, this is the lightest material available. What is the advantage I have it here? Because when you have a lower density, you can carry more material in a truck, so that cut down your transportation cost, and you can save a lot of fuel here, in terms of material handling. It is very lightweight. When you design your structure based on AAC product, yes, your dead load of the structures like your beam, your columns, your floor, this comes down, that constitutes almost 30% the weight of any structure. You cut down it by 1/3 with the density you are designing at 800 kg per cubic meter. It also reduces earthquake reduced forces, because the whole, we know the concept here, force equal to mass into acceleration. The mass is reduced, so earthquake induced forces also comes down here. It can, if you see the size is much bigger, so you can do much faster construction using this material. Fire resistance, yes, it is 100 and 200. This lowest thickness I'm talking about 100 generally. These two thicknesses are used for any wall, like internal wall 100 and external wall 200 sir. So in a typical non-load bearing conditions, 100 will offer resistance of 2 hours, and 200 block will give you fire resistance of 6 hours. This material also can be used for fire protection applications, like you got a steel column, you want to jacket it, you can use this material. Any steel, or similarly the shaft wall, staircase wall, corridor, and firewall, you can use it. This will induce more fire protection, because this doesn't catch fire, this material. That's another unique property of the material. Thermal insulation, the most important factor today. Whole world is talking about controlling this carbon dioxide emissions and greenhouse gas emission, everything we're talking about. This is the product. When you create, if you look at my earlier slides, I've seen that the K factor, thermal conductivity factor, that determines the thermal efficiency. It is only 0.16 on an average. If you take it 0.2, it is much lesser than any other walling material. So that will help you to design your structure, design your envelope in such a manner that will cut down your energy requirement drastically. If you're designing your residential, even if you're not going for any air conditioning system, the normal level of comfort will be very high when you use this kind of material. And also, why it is happening? Because if you look at the production of the process, when you're using aluminum oxide as a foaming agent, like it's a typical mold, because of paucity of time, I'm not sharing those production process, but broadly, it's a huge mold. Suppose it's a 6-meter long mold, and you're pouring all your raw material, lime, fly ash, cement, and other products, and then you're adding aluminum powder, then whole mass pops up like the bread. Then you turn the mold, take the cake out, the cake in the grain stage, it goes to the profiling sections, then you do the horizontal and vertical cuttings. And because of this aeration only, the whole mass pops up. And because of that, a lot of tiny air pocket is created in the things. And that gives, air pockets, the insulation and lightweightness. So that's the unique feature of this product. Another important factor for, again, because of thermal efficiency, like when you go for any energy efficient designing, this factor is very important, RETV. RETV stands for here residential envelope transmittance value. The RETV value is a matrix that, it is already mentioned in ECVCR and Eco Universal Samhita. Now we call it, it is a average rate of heat gain through a residential building's envelope. So AAC's unique thermal insulation properties helps in reducing heat gains from building envelope, thereby improving the thermal comfort and reducing the energy or electricity requirement for cooling. If you look at typically the transmittance factor, U factors here, it is 0.78, 0.55 without doing anything. The number, I think, as per ECVC, you are looking at something close to 0.42. So if you look at the the thickness of the block, 300 mm, without doing anything, only do plastering, you will achieve 0.55, very close to 0.42. But do some jacketing, do some plastering, do some, EPS, you have it. So that's the biggest advantage of using this kind of material. Now I'm talking about the sustainability parameters of AAC. If you look at CPWD Sustainability Index, they have published in their book. So if you look at the parameters, 12 parameters, most of all these features, the parameters being AAC meets, like recycled content, they talked about, the weightage is very high, 10%. Like it is, you're using industrial waste. So you're qualifying here. Embodied energy is a very low embodied material because of fly ash and other factor in it. Rapidly renewable, yes, to certain extent. Locally available material, yes, across India. There are more than 180 manufacturers across India. So this material is available now. Functional life period, yes, this life is as good as your conventional construction, conventional concrete. Its capital maintenance cost is very less. So fly ash contents, specifically, we are conforming this requirement also. Reduced weight, yes, AAC reduces weight, it reduces time of construction. Indoor air, there is no dampness, kind of like efflorescence you'll find in brick, the clay bricks, because of that, a lot of dampness, those factors comes. Here it is nil, because we are not using any clay material. There is no cement, like, salt in it. Those create those kind of efflorescence effects here. So this is another advantage here. Yes, this product is being, certified by green as a Green Pro, this we have already taken from CII, because it conforms all their conditions, eco-level conditions. We have this product, and also Griha Council, they've all certified this product. They've got different criteria. It fulfills all the criteria as a sustainable product. Now I'll just take you through the typical comparison, conventional concrete, and now we're talking about AAC concrete, which is a green concrete. We are saying, so how and what are all parameters differentiate from your conventional cement concrete. Raw material, like conventional concrete, we know cement, sand, natural aggregates we are using, but here AAC, we're using cement, lime, gypsum, and fly ash. Or in case of fly ash, you can also sand and aluminum powder. This is a component here. Use of industrial waste, that component is not there in conventional concrete. It's very limited, but ours is a major, 55 to 60% are using is fly ash. Cement consumptions, in case of when you do anything with this in a conventional concrete, is very high, cement consumption, because the major binder is in the cement. But here, in our case, it is less because lower due to fly ash and lime and other component, and also because of the process itself, AAC manufacturing process, because you fill up to 2/3 and you get another 1/3 extra. So, you're putting 1 cubic meter, you're getting, more than 3 cubic meter of material, something like that. So that's why it says very resource efficient. The density, if you look at conventional concrete, 200 to 25 kg per cubic meter. If in contrast, you take it 550 to 700 kg. Even you take the design density, 850, 900. So it's 1/3. So that cut down your dead load, I have already mentioned here. Embodied energy is very high in conventional concrete, but it's very low in case of AAC product. Cardboard fit naturally, it will be high, and it is 30 to 40% lower than the cement concrete. Thermal insulations in the conventional concrete is very poor. You won't get, because of direct conductions, it has been compacted and is very, because of that, insulations is not efficient. AAC is excellent material. Water consumptions, you need the on pre-curing, post-curing, a lot of activity to be done. The water requirement is very high when you do this kind of conventional concrete. But in our case, you require very minimum water. There is no post-curing, like post-curing do not require, when you apply this block in a masonry, in a wall, you do not require any curing at the later stage when you erect the wall. Construction energy is very high here. In AAC, it's very low. Impact on natural resources, in we're using industrial waste, but when you go off conventional concrete, you have to consume sand and stone. You have to utilize because you need an aggregate. So that aggregate comes from the natural resources only. Operational energy, that potential is not there in conventional. That's very, very minimal. You have to design, you have to create hollowness, or those kind of things you have to incorporate to have that benefit. But here it is significant. Your operational load will come down drastically because of the thermal efficiency of the product. Is green certified? Yes, conventional concrete also it can do partially, but if you look at in terms of point and scoring, AAC scores very high here. So to wrap it up, why we are saying and what is the rationale of using this material? First of all, high fly ash utilization. It's an industrial waste management. So AAC can help you, getting that. It has got very lower embodied energy and carbon dioxide emissions is being controlled in the manufacturing phase and throughout the life cycle of the product. And it has got excellent thermal insulation, and so it ensures the building becomes very, very energy efficient. Even if you are not going for air conditioning, the normal comfort, thermal comfort will be very high. Even for, if you're going for economically weaker section houses, affordable housing, a lot of programs are on under Prime Minister, the relief funds. So this is really a boon for the industry, this kind of products. And of course, it conserves the natural resources. I do not use any, natural resources, which is getting scanty with the passage of time. We're using more of industrial waste. So AAC contributes strongly to the sustainable construction practices. And it's not a new material anymore, Worldwide, it's more than 100 years the product is in use. And in India, of course, it's more than 40 years this product being used in all forms. So it is tried and tested. It is all-weather material. So we look forward. There is a lot of support requires for the government, because in spite of its so much uses, and it is now more than 180 manufacturers, I say, across India is available. But if you look at in terms of replacement, the walling material is not even 10%.